This is Charles with Alex-Tronix Controls, and this is a brief overview of our Models F4 and F8 filter backflush controllers. Same information also applies to our F12 and F16 controllers, but these knobs are laid out in a little different fashion. All of our controllers will flush the filters based on either periodic time, manual start, or pressure difference across the filters as measured by the gauge at the bottom of the box. And that is adjustable inside the box by a knob on the actual gauge face where you can read the pressure that's currently across the filters. One of the ports, the high port, goes to the inlet of the filter system. The low port goes to the outlet of the filter system. The programming is pretty simple. We have a 3-position selector switch here, function switch. You want to make sure that's in the run position, otherwise you're locked out of starting a flush. Periodic is adjustable from 15 minutes up to 48 hours, and that will be set based on the quality of your water or how often you want to turn the filters over, regardless of the pressure loss across them. In some sand media filters, you may want to flush them periodically just to make sure that the sand does not settle out and impact. Timing selections on these models is adjustable in both minutes and seconds cumulatively. A typical time for a sand media filter might be 2 minutes or 90 seconds flush time. A screen or disc filter may be only 30 seconds or so, and it depends on flow, volume, pressure you have to backflush with, so you'll need to experiment with your own system to determine what works best for you. And then dwell is the amount of time in between filter tanks. So if you have a valve that takes a long time to open or close, you want to make sure that the dwell is at least as long as that valve takes to operate. For most large systems, 10 or 15 seconds would be a typical time to allow the valves to transition. In initial setup, you're going to want to determine which solenoids you have. These controllers can operate either 12-volt DC or 24-volt AC latching and 12-volt latching, with the provided transformer. If you do not use the provided transformer and are operating from either a battery or a solar system, you will only be able to operate in the 12-volt DC or preferably 12-volt DC latching mode to conserve power. Wiring of the system is straightforward. We have a single common, our individual solenoid outputs for the individual filters, an alarm, and a master. And one wire from each solenoid would go to common and then to its corresponding other terminal. This is a 4-station controller, but if we only had 3 filters, you would wire to 1, 2, and 3 and leave 4 open, and we'll go over the programming of that later. Master is for a pressure sustaining valve, so if we have limited flow and we want to close the outlet of our filters to the field to build up enough pressure to backflow, we would put a electric valve there and operate that here. Alarm is a feature where if this controller backflushes 3 times consecutively off of pressure only without going back to normal operation in between, this output will turn on so we can have a light or something and notify someone that there may be a problem with the system. The transformers used in these controllers is a 24-volt center tap transformer. The standard transformer uses yellow, orange, and yellow wires. To test this, you would measure across the 2 yellows and you would get nominally 24 volts. It's typically a little higher, 26 or even up to 28 volts maximum, with half as much between the yellow and the orange wire. If you're not getting that, then something's wrong. We suspect your transformer of being bad. If you're using a battery or solar setup, we recommend removing the transformer altogether, because if a battery is wired in parallel with this transformer, it would be a dead short and just simply burn up everything here. On initial setup, you're going to need to program these switches at the top of the back of the panel. The timing selections for pre-dwell and PD settings can be found in the lid of the box listed here, and they're cumulative. For example, if we wanted a pre-dwell of 15 seconds, we would switch number 1 on, which would be this first switch numbered 1, flip that up, and that would be programmed. Likewise with PD, we follow the same chart. So if we want 30 seconds PD delay, which is a typical value, we would switch 2 on, and they are cumulative all the way up to 180 seconds for PD delay and 105 seconds for pre-dwell. So for example, here we already have our second switch up for 30 seconds. Default setting for most systems is 30. Pre-dwell you need if you have a pressure sustaining valve in the system, and that gives time for that to close to build pressure to flush the system. If you do not have a pressure sustaining valve, that can just simply be left off. Our station selectors here determine how many stations the controller will step through before returning to idle. This happens to be a 4-station controller, but if we only had 3 stations, we would simply turn the first 3 switches up, leaving the 4th down, and when it gets to station 3 and finishes the flush, it would go back to idle. The last switch is latching or steady, and again, that is determined by which type of solenoids you have. More often than not, you'll have steady or regular solenoids that require continuous power to stay on. Latching will send a pulse one direction to turn the solenoid on and a pulse the other direction to shut it off. This is typically used in battery or solar powered systems. Additionally, at the bottom of the panel we have our AC-DC selector switch. If you have AC solenoids, this would be switched up. If you have 12 volt DC or DC latching solenoids, this would be switched down. As mentioned before, these controllers have an alarm mode. If the controller encounters 3 back flushes based off of pressure without going back to normal operation in between, it will go into alarm mode. It will say alarm. And to get it out of alarm mode, you move your function switch to the middle, alarm reset, and hold down the button. That will clear the alarm. Additionally, if we want to reset our displayed backwash cycle count, we move the switch to the bottom again and hold it down for a few seconds, and that'll clear that value. Some people like to do that every time they service the controller or are near it, so they can come back and get an idea of how often it's flushing, if they've got a problem with too much effluence getting into the filters, or if they need to adjust their backflush times. If you have a condition where the controller is running but the valves aren't engaging, you may have tripped your circuit breaker, which is this button here. Recent controllers have a light here that will come on when that circuit breaker has been tripped. So simply push it, and sometimes you have to push it in pretty hard to get that to reset. If it immediately trips again, if it happens to be in backflush, go look at your wiring and your solenoids. You may have a short. Now, for a while we could not get these circuit breakers, so we actually used fuses, and those would be located in this lower portion of the back of the panel. We typically include an extra one on the back to stick in when we did use them. And then before that we had circuit breakers, but we did not have this light feature yet. So panels that are more than 10 years old may have a breaker without a light. Again, suspect the breaker if your controller is functioning but the solenoids are not. The most common causes of failure we have on these controllers is on our initial setup, wiring the transformer into a voltage it doesn't want to see. Within the last 15 years, our transformers have directly stamped right in them the voltage. For example, this one's 120 volt AC. That's all it wants to see on the input. We do find situations where people wire these into VFDs, not realizing they're wiring them into VFDs, and they don't like that. You get real erratic behavior or just burning up of the controller. Additionally, people sometimes will wire this to a stinger, 170 volt stinger, or a 120 volt transformer into a 240 volt circuit, which of course immediately burns up the transformer. The second most common cause of failure is just simply leaving the box open. You wouldn't put your computer out in the rain. You shouldn't leave this out in the rain. Most of our controllers have a latch that'll hold them shut. If this gets damaged, just go ahead and put a bungee cord around it, because it's better to do that than to have to send it in for repair. And then past that, most problems are solenoid and valve related. Now, we do try to help as much as we can, but since we do not provide the valves and solenoids, a lot of times we can't do much for you other than try to get you in contact with the filter or valve manufacturer. We will do what we can, but there's only so much we can do with those types of problems. If you need assistance with your controller, you can contact us by phone at 559-276-2888, and we can walk you through troubleshooting procedures. If we determine that your panel is bad, it can be disconnected and sent in without having to unmount the entire box. We will run you through a procedure for testing your transformer and also have a look at your wiring harness to make sure there's no breaks in the wires heading down, because of course that's staying in the field, we cannot test that. We'll also ask you to have a look at your pressure gauge to make sure it's not showing any signs of having internal damage or something else that will need to be done. Take the panel to your nearest Alex-Tronix distributor and they will send it in for you. If necessary, we do have loaners available while yours is being repaired, and typical turnaround time is a few days for repair on a panel. Things do happen. We have not changed this basic design in about 25 years, so you're relatively assured availability of parts. Even if you really blow up the panel and we cannot repair it, we will have something you can replace it with, so you don't need to redo the entire system.